Hi everyone, I am back. Sorry I had to make a couple of different videos here. The rain has put quite a damper on my internet service. I have satellite internet, so it's throwing a kink into my plans here. So anyways, we are looking back at our work to say, are we correct with our findings? Was our method a good one? Did we actually find the area of these trapezoids? Or do we need to take a second look at our process? And so what we're going to do is we're going to maybe ask ourselves, could we have used a different strategy to come up with the same result? So could we have used a different breaking down of our trapezoid in order to calculate those areas? And so to answer these questions, what we're going to do is we're going to select a different strategy, and we're going to calculate using this different strategy and make sure that we've actually come up with the correct area. So we're just going to double check our work from the first set of results. And so what I've done here is I've already set up the work to try and save some time on this video. Again, we go through our base and our height and our larger base for all of them. It's the same trapezoids that we went through in the first example, but now we're going to use a different strategy. Before we had used break it down into two triangles. Now we're going to lop off the two triangles on the side, and we're going to find the area of all three figures. Once we have all three areas, we add them up, and then hopefully we get the same answer we came up with before. That way we'll know if we have a good strategy or not. And so the first one, we have the rectangle plus the triangle on the left plus the triangle on the right is going to give us our total area. So our rectangle's area is 4 by 6, and our two triangles are 2 by 4s. So we have 2 times 4 over 2 and another 2 times 4 over 2. And that gives us a sum of 32. Now, we're going to do the same thing. And of course, if I were, giving this to a group of sophomores, I would definitely make them think all of these things through, and I wouldn't be going through it quite as fast. But I am going through it rather quickly because I know that all of you will follow me. So anyways, we have our rectangle, it's a 3 by 3. We have our two triangles that are also 1 by 3s. We calculate those areas. They know how to do this, and our total area is 12. Now, I've done this for all of them, including the right trapezoids. These ones, we only have 2 figures that we need to add because we have 2 right angles on this side of the trapezoid, so we end up with a rectangle and a triangle. So one less figure to calculate in. The acute trapezoid, acute scalene trapezoid, that one is the same as the isosceles trapezoid, only the two triangles are different size. Now the obtuse trapezoid was a little bit different because one of the triangles is upside down because of this obtuse angle here. So that one was kind of neat to think about and look at. How am I going to use this strategy on this one? Now when we compare our answers, this is, I could do this, with 3 different strategies, but the point of it was to check our answers with our first strategy to find out, did it work? Were we on the right track? So I've made a table of the values that I came up with using method 1 and using method 2. And it turns out that we did get the same answer both times. And so our area calculations are correct using either method. And so this is just one way that you can support your answer by taking a second look at it and saying, hey, what could I find this answer a different way? And that can help you support your answer and be more confident in it. So now, as an extension, a possible extension for this, I might ask my students, can you write a formula now for the area of a trapezoid? And so the formula can actually be derived from all of the work that we've done. So you could use these items right here plug in variables for the big base, the little base, and the height, and you'll end up with your trapezoid formula. Or you could go backwards to this one, plug in again your big base, your little base, and your height for the numerical values that we had, and do some simplifying, and you'll have your trapezoid formula. So that's one extension that I might give to my students that are maybe a little bit more ahead. Can you write the formula using variables? And then another possible extension might be, can you find the area of a regular hexagon? Now, a hexagon, I mean, if you break it down, is two trapezoids put together, right? So the point of that might be just, can they see that? I think that sometimes students get stuck, well, it's got 6 sides, this has got 4 sides, I don't get the get where to go with it. Just asking them to play around and see this connection might be good. And then, can you find the area of a hexagon with opposite sides congruent? Now that eliminates the regularity of this. So we take our, whoops, sorry, looking for my hexagon thing here. Okay, so we take our hexagon, but we make it not regular by stretching it. Opposite sides are still congruent, right? But it's not regular anymore. And so that might also get them to think a little bit about these things, and just give them a little bit extra to think about in extending this knowledge to other figures as well. That is all I have for you. Sorry this is in 2 videos. Like I said, I was having some technical difficulties there with my internet. But thank you for hanging in there for me. Bye-bye.